Okay, so this is example 4 now, using I think some of the trajectory stuff we looked at possibly in the earlier video. You've seen that. So projected from ground level with speed of 7, so we're given the speed, angle of theta above, but we're given this information about tan theta. So this is a way they can give you some information without telling you the angle. X and Y are going to be the horizontal and vertical displacements. From the point of projection, find an equation. This equation is more an accurate term. Y in terms of X. So displacement, so again we're using this formula. This is about trajectory again because it's about its displacement, although it's not quite as unknown heavy as the previous video I did. If we consider two things, so one is this tan of 5/12. So in pure math mechanics, they might give you a trig function and you need another trig function. So experience with some projectiles will tell you probably need cos theta and sin theta. So we've got a trig function and we need the other two basic trig functions that go with it. So I'm going to draw myself a right angle triangle. This is going to be theta. I know that tan theta is equal to 5/12. And I know about this idea of SOHCAHTOA. So the ratio for tan theta is the opposite length, so that is 5 over the adjacent length 12. So those, it could be 10 and 24, but it's just about ratio. We then would need to find the hypotenuse. I think this is a Pythagorean triple, so it's 13. Or you can use your Pythagoras and check that. So I can now say that sine of theta, which I will need, is equal to the opposite over the hypotenuse, so 5/13. And cos of theta, which is the adjacent over the hypotenuse, is 12/13. Okay? Turn this ruler off. There we go. I'll get rid of this just to make it slightly less cramped at the bottom. Right, that's bigger actually now. So 12/13 adjacent over hypotenuse. And I think it's still important, even in mechanics, not to just use tan -1 and get the angle. So in pure maths you would get 0 marks. In mechanics you may lose some credit if you just tan -1, but you would maybe still be alright with the question. If you do it in pure maths, the whole question you are not going to get marks for, because that's the point of the question. So horizontally, looking at my SUVAT variables for this equation, S is the displacement, which we told is X. U, well, we've done this a few times, so you might be comfortable now. If we start at 7, this is theta. This here is going to be 7 cos theta, which we now know is 7 times 12/13 for this question. This is 7 sine of theta, which should be 7 times by 5/13. So for the horizontal, 7 cos theta, 7 times 12/13. Specifically for that angle. V we're not interested in. A horizontally is 0, and T is just a variable of time. So assuming that we're now happy that we're going to use this formula here, it's going to be X equals, and I might maybe should write that down that I'm using that. X is going to equal 84/13 T. Again, A0, so that bit is not going to be impactful. If I do the same vertically, S is going to be the Y, U is going to be U sine theta, so 7 times by 5/13. B again, not interested. A, we're going to generally take upwards as positive because it's projected upwards, so that's negative 9.8. I'm not going to use G because it says about the number. T again is going to be the as yet uninterested, so it's just a general time in this question. Again, same formula. This time Y equals 35/13 T, and then a half, so A is 9.8, so minus half of 9.8 T squared. It's then just going to be a case of getting rid of T. So we suggest the best thing to do is to rearrange this equation, make it t equals, put it into the other one. Okay, so if we do that, we should be able to see that t is equal to, and I think when you take the 84 over 13, it's going to become the reciprocal on the other side. So 13x over 84, or 13 over 84x if you'd rather. We'll call this equation 1. We'll call this equation 2. And I'm now going to substitute this into equation 2. Okay? So I'm going to have y equals 35 over 13 lots of 13x over 84. Take away 4.9 brackets squared of the same term. I'm going to use my calculator for that. I think I can do the first term alright. That looks like 13, they're going to cancel out. The first one's going to be 35 over 84, although I think, because I think in the last video that was tan theta, that's actually just going to become 5 over 12x. I think that's what 35 over 84 is going to cancel down to. Take away, and this is going to be 4.9 times 13 over 84 squared. So that looks like as a fraction it's going to become 169 over 1440 x squared, which is 13 over, I say 13 over 12 squared, but it's not. Something to that, 13 squared over 10 lots of 12 squared. Anyway, not that seems to be relevant. And I think that's what we're going to get for this question. Okay, should be an equation. Similar kind of idea. Y in terms of x is this kind of trajectory thing. It doesn't use the word trajectory in here once, but that is generally what you're going to go for. You might not even notice, you might just be getting up to your Subats and then trip into the idea later, if you will. Really important, this idea of changing. If you go from, if you have a trig function, a jack trig value, and go to another trig function, you can't go via the angle, you have to go via a different method. The alternative to this is using trig identities. Having said that, if you're given tan theta to begin with, or tan x, it's harder to go from tan to sine and cos without the triangle. With the identities, it is from sine and cos, because of the nature of the way the identities work.